what it measures. If it's not long enough to go through the other part of the protractor, you can use a straight edge on the protractor to draw it longer. Okay. And we'll talk about what I mean by that. So, first of all, let's talk about the components of an angle. So, an angle is made up of two rays. So that's why we're talking about rays at the beginning. So a ray has one endpoint and extends infinitely in one direction. That's not new. We learned that day one. This would be. Always label with what first. So I'm talking about a ray. Like that, and then I do letters here. What goes first? Same.
Oh, you always start with
The end. Then do you remember what opposite rays are? We're just going to review for tomorrow. Lily.
There are two rays that have the same endpoint as one opposite rays.
Yes. So, collinear. Collinear rays. Same endpoint. Collinear means they won't time. So if I were to have a ray going like that, another ray going like that, and this was 180 degrees, this would be opposite rays. Can opposite rays ever overlap? No, because if they overlap, then they wouldn't share the same endpoint. So that brings us to angles, are formed by two non-collinear rays with a common endpoint. Now I guess technically, this is still an angle, it's just a straight angle, with collinear makes it straight. But all the other angles have two non-collinear rays. So they're made up by sides, the sides. So ED and EF are made up of two rays. So ray ED and ray EF. And the vertex is the common endpoint. So angles still are two rays that share a common endpoint, it's just that they're not collinear anymore. So there's three ways we can name an angle. We can name it using the three letters. So the vertex and then an endpoint over here and then point on the other ray. But the vertex is always in the middle. So whenever you see an angle like angle DEF, whatever letter is in the middle, that's what the vertex is. So this is your vertex. So if I were to do it with RA, I would say angle DEF. Now see this little angle notation I have here? That's how we specify that it's an angle. So if I just say DEF, I'm talking about a plane, right? I'm not talking about a plane, I'm talking about an angle. There's another thing you can add to it. You can add this little arc symbol to denote an angle rather than like a less than sign. So that's sometimes helpful. Or, I guess I'll say or you can name this the opposite way, FDD. So angle FD. Now I just couldn't name it, say like angle DFD because E has to be in the middle. You can't name it angle DDF. The other way you can name it is with one letter. So I could say just angle E. But I can only do that if E is not the vertex of another angle. So only if E is not the vertex of another angle. Also, sometimes when I do notes, I shorthand angle. I don't say angle, I just don't kind of like do it. Here's what I mean. You don't have to do all this, but you can watch up here. If I had another ray going like this, I labeled this, I call this A. And I said, I wanted to name this angle, so I say angle E. Okay, am I talking about the entire angle? Am I talking about this angle, or am I talking about this angle? I don't know. So in that case, if E is a vertex to more than one angle, then you have to specify with the 3 letters. So if not, then you have to do it this way. Or if I had it coming out this way. Once again, if I just say angle E, am I talking about this angle, or this angle? In this case, I would have to specify using the 3 letters which angle I'm talking about. All right, and then the last way to do it is kind of like the one letter. You can do it with one number. So sometimes if your angles are labeled, this is like angle 2, you can use that number. So this would be angle 2. Sometimes you'll have a diagram that doesn't have any letters in it, it just has numbers. Okay, so here, I think these questions are referring to this diagram. Angle CFD. So to read this, we go from C to F to D in that order to figure out what angle we're talking about. So we go from C to F and then to D. So if you need to, you can like trace over what angle you're talking about. So we're talking about this angle here. And length are the same. So in other words, what's another name for this angle? Alan? Yes. And this is the order. Can I say the F? Oh wait, could I say angle F here? No, because F is vertex is the vertex to a lot of different angles. Can I say BFA is the same as F? So BFA, so this angle right here. No, and that's kind of the same idea. Because F is a vertex of lots of different angles. And then can you say angle BFA is the same as angle 1? Yeah. Angle 1 is specifying this angle right here. So that's fine. Not talking about this angle, this angle. Okay. So measuring, angles are measured in units called degrees. When you get to more fancy math like calculus, and you might get to it if we have time for extension problems, angles can also be measured in what's called radians, where 180 degrees equals pi radians. Just a little bit for you to be concerned about now. And you can use a protractor to measure angles placed at the center point of the protractor over the vertex. The line is marked for the 0 of the protractor with one side of the angle. And then we can measure of angle ABT is abbreviated as M before the angle name. Like, so you put the M here. So whenever you're saying, whenever you're reporting the measure of an angle, you just put the M in front. Now, acute angles, if the measure is greater than blank but less than blank. So what are our acute angles? Degrees. pardon. 0 and 90. And then 90 degrees is your right angle. You can put degrees in here. Or and how they're doing that. That's our label. Kind of like if you were to label P. Say 90 degrees. Obtuse is if the measure is between push. Yes. 90 degrees and 180. And then straight is if it's 180. Now what about everything greater than, what about between 180 and 360? In that case, we don't report measure, well, measuring an angle, then you would go, like, for example, you had it right here, and then right there. If I lined up my protractor here, this wouldn't be this would be technically like, would be like 270. But we wouldn't measure it that way, we would measure it this way, right? So if you're reporting measures of angles using a protractor, you're never going to go greater than 20. You know, line up your protractor so that it fits the protractor between 0 and 1. Okay, so next page. Let's practice using our protractor. And then, so measure each angle, write down the measurement you get, and then classify according to measures. Just do to the nearest unit, like you don't have to worry about like 0.1 or 0.5. So if you're not familiar with using a protractor, I'm going to try my best to use this thing. Oh. So you put this little mark down here on the vertex like that, and then you line up the black part with the ray, and then I see, where does it go through? Now, is it long enough? Is your ray that you have there long enough? No. So what you need to do is take your straight edge and extend the angle. So, for example, I would take my protractor and I would go like that, and then draw it to the end of the page so that my protractor fits it. So I would do that first. And don't assume anything. Don't assume if the second one is 90. Why not be? If it's 88 or 89? Yeah, always double check. Yeah, classify them. So you can be up to right. Abbreviate what? Like that. This is about 100. Okay, so for the first one, I got about 55 degrees, so that would be acute. The second one, I got 90, that would be a right angle. And then for this one, I got about 118. So anywhere between them, like within 2 or 3 units. I could put 115. Okay, put 120. And not really, but okay. Close. So that's all. Is there anyone who needs help seeing those? You get your sheet out. Okay, so if I move, let's move on to the second part of that page. So congruent angles have the same, any guesses? Same measure. So, yeah, the same measure in degrees. Degrees is like, according to the picture, fill in the blanks. So angle 1. Now, important, when, you know how when we had segments and we mark congruent segments with like that little dash mark? So we do a similar thing for congruent angles, except we do arcs. So these both have, angle 1 and 2 both have one arc, then they're congruent. If they both have 2 arcs, like if I drew 2 arcs there, they'd be congruent. I can draw 3 arcs or 4 arcs, depending on how many different angles that are congruent I have in the diagram. So if angle 1 and 2 both have one arc, we can say that they're congruent. So draw angle 1 congruent to angle 2. Now, similar to segments, we say that segments are congruent, their lengths are equal. So when I talk about then the measure of angle 1 and 2, we say that the measure of angle 1 is equal to the measure of angle 2. So I don't say that the measure of angle 1 is congruent to the measure of angle 2. I'm talking about the numbers, the degrees now, instead of just the geometry. So angle 1, well, we know that angle 2 is 70, so angle 1 has to be 70, right? So what does that make angle 3? Yes, how did you figure that out? Yes, sorry, this is minus 9. 180 minus the 70 that, or the 140 that's already there, gives us 40 left over for angle 3. Because this is straight angle, so the whole thing is 180. All right, an angle bisector. Similar to a segment bisector, the segment bisector is anything that cuts through a segment at a midpoint. A ray that divides an angle into 2 congruent angles. Now there's not like a midpoint of an angle. We can say that it bisects it. So if ray BD, this is a great symbol, if ray BD bisects angle ABC, then angle ABD, so this angle right here, is congruent to an angle BBC. So then go ahead and mark them congruent. Now notice that when I did the arcs, I did them like not right with each other. I put one here and I put another one a little bit out, just so that they don't look like one continuous arc, so they're 2 separate arcs. It's okay if you do that, as long as you don't do like 1 arc here and 2 arcs here. And then their measures are also equal. The numbers over here the same way. So that's an angle bisector. And then, remember how we had the segment addition postulate? The 2 segments add together, and they, the point in between them is between the 2 endpoints. Same thing with addition postulate. So if R, point R, is anywhere between this angle, we can say that this angle, top angle plus the bottom angle equals the entire angle. So angle P to R plus angle R to S is equal to what? Yes. So here we'll see, be careful, not all of them are bisectors. We have to see in the problem that they're bisector. So number 1, we are talking about a bisector. Number 2, there's no indication that you have a bisector here. So you can't just say this equals that, you can do something else. Alright, so for this one, if you know that ray BD bisects this angle, we want to find the measure of angle ABC, so the whole thing. So what sort of equation did you set up? So we need to solve for x, right? Maybe we plug x back in, figure out one of the angles. So what What would our original equation be? What are you gonna do? Cameron? Yeah, set them equal to each other, because now we know which part's x, and those are equal. So 3x plus 17 equals 7x minus 89. We're gonna subtract 3x, add 39. Equals 4x. So x equals 14. 7 equals 14. Right. Now then, once I get x, you have to plug it into one of these expressions. And instead of doing both expressions, I would just do one expression and then double it to get the entire answer. So then what's 3 times 14 plus 17? Well, 3 times 14 is 42. 42 plus 17 is 59. And if I double that, I get 118. So 118 is finally any questions about that one? Okay. Number 2. Once again, we can't set them equal to each other because it doesn't say that D is a bisector. But they did give us the measure of the entire angle. So we could use angle addition postulate. We could use that postulate up there. And say that this plus that equals 145. So let's do that. 7x plus 11x plus 9 equals 135. Add up your 2 x's. 18x. Subtract 9. So 126. And then if we're lucky, 126 is divisible by 18. So 7. Okay, so x is 7. Now it says to find angle BDA. So BDA, and we would need to just plug it in. We just get 49 times 7, 49. It should what you do. Okay, so there is no exit ticket for this lesson. Okay, after you're all able to break from this exit. Instead, the practical thing to do would be to do your quiz review tonight. Once you're done with your quiz review, you want to get elastic, we're going to do until Thursday. Okay. We got 2 things to do. Priority quiz review, big priority of this next class. The activities are fun. If you're not happy with your grade, come see me. Try it again if you ran out of attempts. But I'm not going to go hunting you down if you have a 1 out of 2. So I guess I'll leave the protractors on your desk. I don't want you to take them home. I'm just gonna come around and like wipe them with a wipe here. Oh, no, disgusting. Oh, yeah.
I'm gonna use my Clorox wipes that have maybe some less chemicals in them.